Hi everyone, today I'm going to talk about solving systems of linear equations using graphing method. Okay, so let's jump right into our system of equations. Let's say you have x plus y is equal to 7 and then x minus y is equal to 3. Okay, so what we have right now is a system of linear equations. Now when we say solve this system of equations, we're expected to find the value of x, okay, also find the value of y that satisfy the two equations. So we have this one solution if we were able to find the value of x and y. Okay, so if you look at the equation, you can actually guess the number. It's like what two numbers when you add, okay, will give you 7, and at the same time, those two numbers when you subtract give you 3. So you can try say 6 plus 1. Okay, 6 plus 1 is equal to 7. But the problem is when you do 6 minus 1, it's not going to be 3. Okay? So what two numbers satisfy the two equations? What number when you add give you 7? At the same time, when you subtract give you 3. So let's try 5 and 2. So 5 plus 2 is equal to 7. Now, what about 5 minus 2? Okay, so 5 minus 2 is 3. Therefore, we have a solution. X is 5, y is 2. Now, this is considered one solution because graphically, what's going to happen, when you graph those two equations, they are linear equations, so we expect the graph to be straight lines. So what's going to happen is when you solve it graphically, the lines are going to intersect. Okay, sorry about that. Okay, the lines are going to intersect. Okay, let me, okay, messed up with this. All right, so the point of intersection has to be at 5, 2. Okay, so 5, 2 is somewhere here. So expect the two lines to intersect at this point. So the point of intersection is at 5, 2, where x is 5 and y is 2. So a system of linear equations, when solved graphically, one possible case is that the lines are going to cross, intersect at one point. Now that one point of intersection is going to represent one solution. Now, there are two other possible cases when you graph two lines on a plane. Okay, so again, the first case, okay, there's one point of intersection, and that one point of intersection is going to be the solution. So one point of intersection represents one solution. Now, two lines can also be drawn to be parallel to each other. So we have this, okay, parallel lines. By the way, the first one is called intersecting, okay? So we have the first case, intersecting lines. They intersect at one point, therefore we have one solution. When the lines are parallel, okay, they will never cross or meet or intersect no matter how far you extend the lines. Because there's no point of intersection, then we say the system of equation has no solution. Now, in the first example, we come up with one x value, okay, and also we come up with one y value. Those are the solutions for this type of system of equation. When the lines are parallel, okay, and you do it by algebra, you will come up with some nonsensical statement, something like 0 is equal to 5 or 0 is equal to 8, which doesn't make sense, okay? So again, if you do it by algebra, this is something you will see, which is really a false statement. So that implies the system has no solution. 1 point, okay, 1 point, one solution for intersecting, no intersecting points, no solution for parallel lines. And the third case is that when two lines, okay, coincide. So you have two equations, and then when you graph them, they coincide each other, okay? So we call this type of lines coincident. Those are coincident lines. And coincident lines, they have infinitely many points in common, okay? Since we have infinitely many points in common, therefore we have infinitely many solutions for coincident lines, right? So let's look at our first system of equation. The first one that I gave you is this x plus y is equal to 7, and also the x minus y is equal to 3. And the solution that we were able to find are 5 and 2, okay? 5 plus 2 is 7, 5 minus 2 is 3. Now, how do we graph those two equations? Now, you recall that to graph a system of equation, or to graph a linear equation, first step is to write the equation in the form of y equals what? Mx plus b. Okay, so we have to write the two equations in this form, okay? Meaning you have to solve for y. Solve for y, and it should look something like mx plus b, in which the m is called your slope, the number next to x. And this part of the equation, the constant is the y-intercept. And we're going to be using those two, y-intercept and slope, to graph the lines, okay? So let me go back to our x plus y is equal to 7, and let's solve for y, okay? So we have this minus x minus x, so therefore y is equal to what? Negative x plus 7. Okay, so from that y equals mx plus b, okay, so the y-intercept, the b, is 7, okay? Actually, it's a point, so it has to be in ordered pair format. It has to be 0, 7. A y-intercept is a point, okay? It's actually a point on the y-axis. It's like 1, 2, 3, 4, 5, 6, 7. It's a point on the y-axis where the line will cross, okay? And the number before x is your slope. So that's the slope. The number here is understood to be negative 1, which is negative 1 over 1. All right, so that's our slope. So the slope is negative 1 over 1. And we're going to be using rise over run as our guide to determine that second point, okay? So you're going to start counting rise and run from the 7. So rise of negative 1 means you go down 1, okay? So you're going to go down 1 and then run to the right to get your second point. And here's the first line right here. Okay, so go back to this x plus y is equal to 7. Now x and y, they actually represent numbers that when you add give you 7. One example again is 5 and 2, okay? So we have this 1, 2, 3, 4, 5, and then 5, 2, okay? So that point, 5, 2 is on the line, okay? What other numbers when you add give you 7? 6 and 1. 6 plus 1 is also equal to 7. So when you look at the point with coordinate 6, 1, it's also on the line, okay? Or you can have 4 plus 3. 4 plus 3 is equal to 7. So that 4, 3 is a point on the line too. So in other words, the points on this line, okay, the points on this line, the relation of the x and the y is summarized by this one simple equation. Okay, so what do we know about the x and the y's on the line? The x coordinate, when you add it to the y coordinate, the sum is always equal to 7. Right, so that's how we interpret the equation in relation to the line. Okay, so the first equation again is x plus y is equal to 7, and the line is from the y-intercept 7. Okay, so we actually wrote this down as y equals negative x plus 7. So we went down 1 and then run 1. Okay, so this was the line that we got earlier. Now the second equation is x minus y is equal to 3. Again, solve for y. To solve for y, so we go ahead and subtract x from both sides. So minus y is equal to negative x plus 3. All right, so we want to make this y positive, so let's divide every single term by negative 1. So we have y is equal to x minus 3. All right, so the y-intercept is negative 3, and the slope is 1 over 1. All right, so this is your y-intercept. Okay, let's write that y-intercept in ordered pair form. And this 1 over 1 is our slope. So the second equation, you start again with the negative 3 for the y-intercept. Okay, the slope now is rise over 1, rise over run, 1 over 1. So rise 1, run 1. Okay, so 1, 2, 3, 4, 5, 1, 2. Okay. So it has to cross, okay, the first line at this point, 5, 2. So this is one common point. And that one common point represents that one solution that we're looking for, which is x is equal to 5 and y is equal to 2. Okay? And again, you can check. When you plug in the 5 and 2 to the system of equation, all right, the 5 and 2 satisfies the 2 equation. 5 plus 2 is 7, 5 minus 2 is 3. Okay? So we have one case when the lines intersect, get the point of intersection, because that will be your solution. Okay. Now, the second case is when the lines are parallel. Now, when the lines are parallel, okay, let's take two equations, but I'm going to give you the equations that are already in the y form. Okay, so y is equal to, say, 2x plus 1. The other one is 2x, let's say, plus 4. So these equations are already in the form y equals mx plus b, slope-intercept form. So we just have to grab them. So the first y-intercept is 1, okay? And then the slope is 2 over 1, so we're going to go ahead and rise 2, and then run 1. Right, so let's say this is our equation A. Now the equation B, its y-intercept is 4, so 1, 2, 3, 4. That's your starting point, okay? And the slope is 2 also. They have the same slope. So rise 2, run 1. So the two lines, line A and line B, are parallel. Now, because there's no point of intersection, so parallel lines, best way to remember it is like, say, parallel, okay? Parallel lines. There's no point of intersection, no point in common. which implies no solution. Okay, when you look at the equation quickly, okay, 2x plus 1, 2x plus 4, now quickly, it really makes sense that there's no solution for this type of system of equation because you can think of a number you plug into x, okay, and y, and see if there's any combination of x and y numbers that satisfy the two equations. It's impossible to find the values for x and y that really satisfies the two equation. That's why we say for this type of system of equation, we don't have any solution. Okay, the third and last case is when the lines, okay, sorry about that, when the lines coincide, okay? So we call this type of lines coincident. Okay, these are coincident lines, and usually when you have those coincident lines, they are represented by two equations, say y equals 2x plus 4. Now, the other one, let's say 2y plus 4x plus 8. Okay, notice I just multiplied the top by 2. Okay, so I multiply the first equation, all single term in the equation is multiplied by 2. Now, these two equations are actually the same and identical. Like if you look at the second equation and try to simplify it, solve for y. Okay, so when you solve for y from that second equation, you really can prove that this is just the same as the first one. Okay, so those two equations are identical. That's why when you graph them, they coincide. Now, in terms of solutions, okay, what is the solution when the lines coincide? Notice that these coincident lines have infinitely many points in common. Because they have many points in common, the solutions will be what? Infinitely many. Because the lines have what? Infinitely many common points. So we have infinitely many common solutions. Okay? So for that third case. So hopefully this video helped, and thanks so much for watching. I'll see you again on the next video for the part 2.